math people. All right, last real week of math. All right, so let's do a system review this week, or a review of systems of linear equations. All right, so if you guys remember from a couple months ago, well, maybe like 3 or 4 months ago now, we were solving systems where we were solving 2 equations at once. All right, we were solving 2 linear equations that had 2 unknowns, normally called x and y, and we would solve for both x and y. All right, and we had 3 strategies for solving. We had graphing, there's one. We had substitution, and we had elimination. All right, so number 3 strategies. All right, the first strategy, and the easiest, but doesn't always work, is graphing. All right, and the reason it doesn't always work is because some equations are hard to graph. All right, you might have a weird slope, you might have a weird y-intercept. All right, you might not even have graph paper like how I'm doing it right now. I don't have graph paper at home. All right, so I made my own graph, which isn't perfectly accurate, but it's going to do the job. All right, so here's our first system. We have y equals x plus 1, and we have y equals negative 1/2 x plus 2. All right, lucky for us, both of these equations are in slope-intercept form. All right, and if you remember what slope-intercept form is, it's y equals mx plus b, all right, where we have m, so whatever number is attached to the x is our slope, our rise over run, and whatever number we're adding or subtracting is our b, or our y-intercept, where it crosses the y-axis. All right, so when you're graphing, the first thing you always graph is the y-intercept. So in the first equation, y equals x plus 1. Our y-intercept is plus 1. So that is going to be our first point on the y-axis. So I've got plus 1. There's my first point. Then my next point comes from my slope. Now my slope is the number in front of x. Now if you don't see a number, that means there's a 1. So if you have a slope, or an m value, of 1, you can really think of 1 as the fraction 1 over 1. And remember, the top number, or our numerator, is our delta y, our change in y. Our bottom number, our denominator, is our change in x, or delta x. All right, you can also think rise over run. So what that means is I go up 1, right 1, all right, because they're both positive, so I'm thinking up and right. So I go from my point, and I go up 1, right 1, and I can generate another point, up 1, right 1. All right. Generally, once I have 3 points, I feel pretty confident. I connect them with my ruler, which in this case is a Lincoln log. Improvising. All right. Connect them. Draw arrows on your lines. Label your line with its equation, y equals x plus 1. Okay. If you have colored pencils, use a different colored pencil. Second equation, we have y equals 1/2 x plus 2. So we have a y-intercept of 2. So we plot that. You find 2 on the y-axis, put a point. Now a slope of 1 over 2. All right, that's a fraction. All right, the top number is our change in y. That tells us how much to go up by. So we're going up by 1. Our bottom number is our change in x. That tells us to go left or right. We're going right 2. So I'm going to go up 1, right 2. Oh, looky there. There's our intersection point. Up 1, right 2. My graph's not perfect, but that'll do the trick. Connect them. That'll be good enough. All right. Arrows. Label your label your line. All right, and there's our intersection point. It's not perfect because my graph isn't the best, but you circle it. All right, I like to use an S for solution. Sometimes you'll see P for point of intersection. I do S, and then I write its coordinate, which is 2, 3. All right, so the solution for this particular system is 2, 3. So x equals 2, and y equals 3. All right, so sometimes you'll write it out like that as well. All right, guys, so that's graphing. Strategy number 2 is substitution. And we'll do simple substitution in this case. You might be asked to do a little more challenging substitution. All right, in that case, same stuff applies. All right, so I've got y equals 4x plus 2, y equals 6x plus 10. All right, I always use substitution whenever I have like y equals something or x equals something. So if I have a variable all on its own, that's when I like to use substitution. In this case, I have y alone. I know that y equals 4x plus 2. So I'm going to circle 4x plus 2. All right, that's what y is equal to. Well, guess what? Y is also equal to 6x plus 10. So I'm going to draw an arrow here from 4x plus 2 because I know 4x plus 2 is the value of y. All right, so sometimes circles and arrows help you. In this case, since they're both y equals, just think, set them equal to each other. All right, so here I'm going to substitute 4x plus 2 in for y in the second equation. So my second equation becomes 4x plus 2 equals 6x plus 10. All right, now I have an equation I can solve. One equation, one variable, I can do that. All right, if you need to, use your don't call me after midnight strategy. All right, distributing, nope, no parentheses. Combining, nope, no like terms on either side. Moving, yes, because x is on both sides. So I'm going to move the smaller one. You move a positive 4x by subtracting 4x. So we're left with 2 equals 2x plus 10. Addition or subtraction, yeah, I'm adding 10, so I need to subtract 10. So we get negative 8 equals 2x. M for multiplication and division. I need to undo multiplying by 2, so I divide by 2. And negative 8 divided by 2 is negative 4. Negative 4 equals x. All right. Now, you've done a lot of hard work, but don't stop. All right. This is one of the most common mistakes. The students will just stop. They'll find x. Oh, I'm done. Well, guess what? You need to find y too. So what you're going to do is you're going to take your answer for x, and you are going to substitute it into whatever equation you want, whichever one you think is easier. All right. I'm going to substitute negative 4 in for x in the first equation. All right. So I'm going to do y equals 4x plus 2. Rewrite. Or substitute y equals 4 times negative 4 plus 2. And now I'm going to solve. All right, so y equals negative 16 plus 2. Negative 16 plus 2 is negative 14. All right, so here is my solution. X equals negative 4, y equals negative 14. Now you could also write that as a coordinate. So that would be point S, that would be negative 4, comma, negative 14. All right, and you guys could always check these. Remember, when you check systems, you need to check both equations. Substitute your x and your y values into both equations. Make sure you get true equations. All right, if you get a contradiction, you did something wrong. All right, last, my favorite one, elimination. All right, elimination is often used when you have two equations and they're not in slope-intercept form. They're actually in standard form here when you're adding, when it makes sense to add two variables. A lot of word problems require you to add variables. All right. So the first thing we need to get is we need to get opposites. Now sometimes your equations will already have opposites, but in this case they don't. I have negative 6x plus 2y equals 18. And negative 2x minus 4y equals negative 22. I don't have opposites yet. All right, so what I'm going to do is I'm going to pick one variable, either x or y, and I'm going to try to make its coefficient the opposite of the coefficient in the other equation. So in this case, I have a lot of options. All right, I'm going to look at, let's look at the y's here. All right, I'm going to look at positive 2y and negative 4y. All right, they're not quite opposites yet. They have opposite signs, which is a start, but they don't have opposite values. So how can I turn this 2 into a 4? All right, so this one's a negative 4y. I need this one to be a positive 4y. So I need to multiply this top equation by 2. All right, I'm going to multiply the whole top equation by 2, and I'm going to use a distributive property. All right, so I'm going to basically manipulate the top equation to get a new equation that's really the same thing. All right, 2 times negative 6x is negative 12x plus 2 times 2y is 4y equals 2 times 18 should give me 36. Alright, now that second equation I actually don't need to do anything to it because I'll have opposites already. So I'm just going to rewrite this one over here. So I have negative 2x plus negative 4y. I like to call my minuses plus negatives equals negative 22. Now, I have opposites, alright? If you look at our y terms, alright, I've got 4y and negative 4y. They're opposites, alright? That means they're going to cancel out when I add them together. So now, I'm just going to add my two equations together. So, negative 12x plus negative 2x gives me negative 14x. 4y plus negative 4y. Oh, that's a zero pair. That's gone. That's how you know you did it right. You'll get one zero pair. All right. Equals 36 plus negative 22. That's 14. Ooh, this is going to be nice. Now you have an equation that we can solve. It's going to be a one-stepper. How do you undo multiplying by negative 14? Well, you divide both sides by negative 14. And we get x equals negative 1. Very good. Alright guys, now just like substitution, you're not done. We've got to go back in and find the other variable. So you pick one of the equations, one of the originals. Never go to one that you already manipulated. Do an original. Whatever one you think is easier. I'll do the top one. So we have negative 6x plus 2y equals 18. Rewrite. Now I'm going to replace my x value. So I have negative 6 times negative 1 plus 2y equals 18. Alright, I can do negative 6 times negative 1. That's positive 6 plus 2y equals 18. Now we just have a two-step equation to solve. Undo your addition or subtraction first. We get 2y equals 12. Undo multiplication or division. So I'm going to divide in this case. And I get y equals 6. Alright, so there's my solution. X equals negative 1. Y equals 6. I could write that as a coordinate. Negative 1, 6. Make sure you put parentheses around them. Alright guys, graphing, substitution, elimination. Alright, good luck.